Welcome back. The question is, a 1 kg block situated on a rough incline is connected to a spring of spring constant 100 Newton per meter as shown in the following figure. The block is released from the rest with the spring in the unstretched position. The block moves 10 cm down the incline before coming to rest. Find the coefficient of friction between the block and the incline. Assume that the spring has a negligible mass and the pulley is frictionless. So this is the weight, and it's this is the box. Its weight would be acting in this direction, which is downwards. So if it is the component mg, and if this is the angle theta, which is 37 degrees here, so it would be the cos component, that is mg cos theta, and it would eventually be the sine component, which is mg sine theta. The displacement of the block is given as 0.1 meter, and the reaction force is acting in this direction, and mu r is frictional force here. So if r is equal to this sine component, that is mg cos 37 degrees, mu r would definitely be equal to mg sine 37 degrees. Now we can write work done in terms of potential energy as mg into sine 37 minus mu cos 37 into x, which equals to half kx square. So 1 into g into sine 37 minus mu cos 37 whole into x equals half into 100 into 0.1 square. So we are getting the value of mu by equating these two, and it is coming out to be 0.125. Thus the coefficient of friction is 0.125.